All right, so what we're going to be looking at here at the end is exponential growth, and we're going to be looking specifically at money and how it grows when you have a bank account. So one important formula is this, that if we have a bank account and we have money, principal, that's put into that account, the end amount that we will have will be 1 plus R is our interest rate, N is the number of times it gets compounded, here's another N, number of compoundings per year, and T is the total time in years that it's going to be put in. If we have continuous compounding, we have a different formula, A equals PE to the RT. So we're going to be looking at both of these cases. Let's look at number 1. Will invests his $3,500 into a savings account with a 1% interest rate compounded quarterly. Alex, he only has $3,000, but he's going to put it into a CD account with a 3.5% interest rate compounded quarterly. They plan to take out the money when they are 26 years old. They are 18 now. Predict which person will have a higher yield. Then compute the interest. So what do you think, guys? Will Will end up with more money at $3,500 with a 1% interest rate, or Alex with $3,000 with a 3.5% interest rate? You think Alex will because of that interest rate being so much more? Okay, but you got to remember too that Alex is starting out with $500 less. So let's see if she's right. Whether it is going to be Alex that's going to make more. So we're going to plug into our formula. We've got the amount that Will's going to have is going to be his principal of $3,500 times 1 plus his interest rate is 1%. We need to write that as a decimal. So it's 0.01 over the number of compoundings. Compounded quarterly, that means 4 times a year. And then it's raised to the number of compoundings times the time. So they're 18 now, they're going to take it out when they're 26 years. 26 years old. So how many years is that? 8. So this is going to be raised to the 4 times 8. All right, so to figure out how much money Alex is going to have, $3,500, 1 plus 0.01 divided by 4, raised to 4 times 8, or you can just put in 32, of course. Okay, so after that amount of time, Will is going to have $3,000, $3,791.13. Did he make very much money over those 8 years? No, only a couple $100, almost $300, but not quite. All right, so now let's look at the amount that Alex is going to have. He's only starting with $3,000. But he's got 1 plus 0.035%. Okay, so we're going to type that in now. A way I can do it is I could do a second enter, but I'm just going to type it all in over again. Okay, he ends up with $3,964.56. So he does end up with a lot more money. Look at that. He made almost a third of his money. Now, when we're talking about interest, it's proportional. So he made almost $1,000 off of his $3,000. So if you put in $3 million, how much would you make? Almost $1 million. That's why some people say it takes money to make money. Because even at 3.5%, you would make $1 million if you invested $3 million. So it's all proportional. So that's why when some people, they win the lottery, they choose to take a lump sum, because then they can put it into a savings account or a CD, and they can basically just live off of that interest and save up the rest of it, because you'd make so much. Okay, so obviously Alex has the better deal here. Guys, this is also showing you how important interest rate is. See, a 3.5% interest rate doesn't seem that much different from a 1%, but it really does. It makes a huge difference. Let's go on down here now. How much more would Alex have made over Will if he had invested $3,500 at the 3.5% interest rate? So now we're going to take Alex's situation of that 3.5% interest rate, but he's going to invest $3,500. So now the amount for Alex, he's going to start with $3,500, 1 plus 0.035 over 4, still raised to the 32. Watch how I can quickly do this. I can do a second entry, and all I have to do is change his 3,000 to 3,500. And he gets, now he's going to make $4,625 and 32 cents. So a big difference there. Okay, so if he can put in $500 more, then he's actually going to make over $1,000, almost $1,100 something that he'll make. Do you guys know why some people choose not to put money into a CD account even though the interest rates are generally higher? Do you know the difference in a CD versus a savings? No? It's a certificate of deposit. Yep. Yeah, you have to wait until it matures. Like if it's a 5-year CD, 6-year CD, this is an 8-year CD, you're not allowed to take it out. Basically, the bank owns your money for that amount of time. They will give it to you, but you will have to take out the money and pay a penalty. Usually it's like even up to 25% of a penalty. So it's definitely not worth it. So if you get a lot of money for graduation and decide to put it into a CD, that's great, but you have to be willing to not touch it. So you can't say, oh, your junior year in college, I want to buy a car, I'm going to take out that money, because you're going to lose money instead of make money. Okay? The other problem, too, as you're going into college is interest rates for credit cards. Do you guys know what interest rates are for credit cards if you're a new credit card?
You borrow money from the bank, so we have to really pay on that.
Yeah, but do you know what the actual rate is? I mean, specifically? 12% would actually be very good. If you get a new credit card, they usually charge you 18% interest. No. Look at this, guys. Just to make it easy, I want to show you this. Watch. So let's say that we don't make payments. Okay, so we don't make payments. And we have an 18% interest rate. And let's say that we only do this for 1 year. Watch, guys, I'm going to change this to just 1 year. So we're talking about $3,500 and at an 18% interest rate for 1 year. That's how much you would end up owing. And that doesn't even account for the late fees if you don't make any payments. Do you guys know that if you don't make a payment, you get charged at least a $35 late fee too? So let's say you've let those all add up. So 35 times 12. So now you only spent $3,500, but you're going to owe an extra $1,000, and that's just for 1 year. Like a lot of people let this stuff build up over a couple years. Like their freshman year in college, they might get into trouble, can't pay off a credit card. So watch this. So if we did the 3,500, 1 plus that 18%, which is actually a pretty good rate, and then you let it go for the other 3 years you're in college. Look at that. And that doesn't even include your late payments. You're going to owe almost twice as much. If you add in those late payments, you're going to owe twice as much. And it happens to so many people. And, you know, when you get out of college, not only do you have, if you get that credit card debt, you owe that, but a lot of people have college loans. And that's why people start off in such a hole, and you don't want to let that happen. So don't take out credit cards unless you're sure you have a job and you can pay them off every month, or nice parents who will pay them off for you. All right, example 3. Sarah plans to put $3,000 into an account with a 3.5% interest rate compounded continuously. Listen up. So what's the difference between continuously versus quarterly? Does it make a big difference? It's still the same kind of problem, but we use this formula. A equals PE to the RT. The principal we're putting in is $3,000. The interest rate is still 3.5%. The time is still 8 years. So we're going to do 3,000 E raised to the 0.035 times 8. So with that continuous interest, we're going to end up with $3,969.39. This is continuous interest. Okay? It's basically like they're taking this interest rate and dividing it by 365 days, and you get that interest every single day. But can you see how that really doesn't make a big difference? Here's what it was compounded quarterly. Oh, sorry, that's not the right one, this one. Look, this is the one compounded quarterly at 3.5%. This is the one compounded continuously at 3.5%. How much more money are we making? $5 over 8 years. Not a big deal, right? Because sometimes banks will say, hey, if you'll come to our bank, we'll give you continuous interest instead of compounding it quarterly. It's not a big deal. Unless they're going to give you a higher interest rate, it's not worth it to just go for continuous interest. It doesn't make that big of a difference. Okay, part B. What is the rate of change? Guys, what do we do to find the rate of change of anything? We take the derivative. So this is going to be A equals 3,000 E to the RT. We're taking the derivative with respect to time. So the derivative of area with respect to time, amount, is dAdt. To find this derivative, I bring down the 3,000. The derivative of e to the u is e to the u times the derivative of u. We get this. So this problem, though, is asking us specifically, what is the rate of change of A with respect to time at 3? Well, that means wherever I see my t, I'm going to have to plug in 3. And what this is telling me is at 3 years, what's the rate of change of that amount of money? Times points. Okay, so $116.62, that's the amount of change we have at 3 years. So going from 3 years into 4 years, we're going to make that much more money with that situation. Okay? Any questions about interest? Guys, the other thing too, when you go out to buy a house, what are you always looking for with that? Of course you want to get the best deal you can on the house, but what else is important? The interest rate. Okay? People think there's not that much of a difference between a 4.5% interest rate versus a 3.5%, but there is. A lot of times people will even refinance just to get a 0.5% lower rate. Because when you're talking about $300,000 and you've got that interest rate of, say, 4.5%, watch. Usually those are compounded monthly. And you're going to take out, say it's even a 20-year loan. And of course you're going to be making payments on it. This is not an exact science here, but that $300,000 house could go up almost double in its price. You're going to be making payments, so it's not going to quite double, but that's just kind of an approximation for it. So that's at 3.5%. Watch, guys, if I do the same thing now, but I change it up to 4.5%. Oops, that's 5.5. Look at that difference. You see what I'm talking about? That's a huge difference. By a 1%, that's how much we would end up paying for our house approximately. Like I said, we'll be making payments, so that's not completely accurate. If you go under this finance app, did you guys work with that last year, the finance app?
No.
It's really cool. If I can find it, math. I'd have to look for it, but there is a finance app where you can actually put in this information, and it'll tell you exactly what your monthly payments are and everything. It's really cool. I'd have to look, but all right, guys, that's it. Good job.